The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
Okay, so I'm going to work through problem number 17 for Physics 2020, Midterm Exam 2, year 2006. And this problem says a compressed gas cylinder contains helium gas in a volume of 2.0 meters cubed under a pressure of 10 bars at 22 degrees Celsius, which is a comfortable room temperature. What volume will this gas occupy if it is allowed to expand until it reaches 1 bar? Okay, so basically, let's say that we have some container, alright, and in this container we have a certain volume of gas. So we have a certain volume of gas, which is helium gas, and we know it's going to be at some temperature and it's going to be at some pressure. And let's say that now, at some point we open this, we open a valve and we let the gas go into a new container. Okay. And what's going to happen is that the gas is going to tend to fill up the entire volume of the container that it's in. So basically, what we're doing is we're letting the gas expand to a new volume. So what has changed from the first part to the second part, from the first container to the second container? Well, the only thing that's changed is basically the temperature. I'm sorry. The things that are the same are the amount of gas is still going to be the same. Whatever gas we had in here is going to be the amount of gas that we have in here. We're just letting it expand. So the amount of gas doesn't change. The temperature isn't going to change. The temperature is going to be constant because it doesn't say anything in the problem about, you know, we're going to change the temperature. So the temperature is going to be the constant. So if we let N equal to the number of moles of gas, and T equals the temperature, and we know V is equal to volume and P is equal to pressure, we can use the ideal gas law, which says that the pressure times the volume is equal to the amount of moles that you have of a gas times R, which is a constant, the ideal gas constant, times the temperature. Okay? And so if we solve this equation for N, the number of moles, we get the number of moles is equal to PV divided by RT. Okay? Now why do we want to do that? Well, we wanted to do that because we know that the number of moles in our system is going to be the same. So if I now say the number of moles in the first tank is equal to PV RT in the first tank, which is equal to the number of moles in the second tank, right, which is equal to PV RT 2, we know that PVRT1 is equal to PVRT2 because the number of moles are going to be the same. So given that information, I know that PVRT1 or P1V1RT1 is equal to P2V2RT2. Now, R is a constant, so that never changes. And we see that on both sides of the equation, so we can cancel those out. The temperature is a constant, so T1 and T2 are actually the same, so they cancel out. So what we're left with is P1 V1 is equal to P2 V2, right? And let's see what they're given in the problem. They give us the volume of the first tank, which is 2.0 meters cubed. So we know this. We know that. And we know that it's under a pressure of 10 bars. So we know the pressure of the first one. And then we know that the volume, we know that it's allowed to expand until it reaches 1 bar. So we know the second pressure. And then asking us what will the volume of that second tank be if we let it under these conditions. So we're trying to find V2. Okay? So we can solve this equation for V2 is equal to P1 V1 divided by P2. Alright. So the volume in the second tank is equal to the pressure in the first tank, which is 10 bars, multiplied by the volume, which is 2.0 meters cubed, divided by the pressure of the second tank, which is 1 bar. So we're left with bars cancel out, and we're left with just meters cubed, which is volume, which is what we want. And when we calculate this, we get, let's see, we get 20 meters cubed. So in this problem, it went from 2.0 meters cubed to 20 meters cubed. If we allow this to go from 10 bars to 1 bar. Okay? So I guess the way we solved this problem was knowing that we had to use ideal gas law and understanding that that when you have a closed system and you're letting things change by varying the temperature, by varying the pressure of the volume, that the number of moles always stays the same. So if that's the case, we can use the ideal gas law of the system in the two different states. Okay, the first tank and the second tank. That left with just P1 V1 is equal to P2 V2. That allowed us to solve for the second volume, and we had this relationship. And then at that point, it was just simply a matter of substituting in the information that was given in the problem, and we got a volume of 20 meters cubed.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.